Alright, so you've mastered the art of setting up a simple circuit. A circuit like the one displayed here. When we turn the power on, the light comes on. There's only one component connected in this circuit. What happens when we want to add another component into the circuit? Like another light globe. How do we add this in?
Well, the easiest way to do this is to create a series circuit. So what is a series circuit? Well, a series circuit is a circuit in which the components are arranged such that the flow of electrons, or the current, has only one path. And that's the key. All series circuits have only one path. This means that the electricity flows from the positive terminal of the power source, in this case, that's indicated by our battery here, through all of the components one by one. So the electricity would flow from the positive terminal of the power source through the switch first, then through each of the light globes, one after the other, before returning back to the negative terminal of our power source. So what does this look like in reality? Let's jump back in the lab and have a look.
Okay, so we're back in the lab now. We've got our simple series circuit set up. You can see two light globes attached with a switch and a power supply over here. I'll move that in so that you can actually see that. The switch is open right now, and if I bend that up, you'll see that. The switch is open, therefore there's a break in the circuit so that the light globes aren't actually glowing. If I close the switch, you'll see that the light globes glow, okay? The wires are a little bit busy here, but if I show you that, there is only one path the whole way around this circuit. If I get the wires into the shot so that you can see that there's only one path the entire way around the circuit. And that's what makes it, remember, a series circuit. I can add another light globe in here, and there's one thing that I want you to notice when I add another light globe in, and that's what happens to the brightness of the globes when I add more components into a series circuit. To remind you how bright the first the two are in the circuit, have a look at these right now. Okay, we're going to compare that when we add a third globe in. So we'll grab another globe, comes over here, we'll connect it in series again. So we'll get that back in shot. You'll see, you should be able to note, so that we're still with only one possible path for the electrons to flow from the positive terminal, which is over here near my finger, flows through to the switch. The yellow cord then goes from the switch to the first light globe, which the electricity then travels to that second light globe, onto the third, and then back to the negative terminal. Okay, and if we see the brightness of the globes, it should be obvious to you there that the globes are significantly duller or dimmer than they were before. Why do you think that is?
So then, why does the brightness of the globes change? Well, it all has to do with voltage. If you're unsure of what voltage is, perhaps you need to go back and view the video on voltage, current and resistance. Voltage in a series circuit is divided by the number of components in the circuit. If we take the two examples of circuits displayed on the screen, in the first example, let's say the battery provides 6 volts into this circuit. The only two components that are actually using voltage are the two light globes. Let's label them globe 1 and globe 2. If the voltage in a series circuit is divided by the number of components, and we've got these two light globes being those components, if there's 6 volts going into the circuit, how many volts do you think each light globe will get? Hopefully you suggested that each light globe will get 3 volts, because 6 divided by 2 equals 3. Let's have a look at the other example where we've got 3 light globes connected in series in this circuit. If we put the same 6 volts into this circuit, how many volts will each of the light globes get in this instance? Once again, hopefully you suggested that the answer is that total 6 divided by the number of components. In this instance, it will be 2 volts each. So you can see that in the first circuit, we've got the light globes having 3 volts. In the other circuit, they only have 2 volts. And that's what provides the difference in the brightness of globes. Current in a series circuit is simple because current remains constant throughout a series circuit. This is because there's only one path for the flow of electricity to take. And while this doesn't affect the brightness of the globes, like voltage does, it does mean that if you've got a switch in your circuit, it's going to control all of the light globes. It's not possible to open a switch and only have one of the light globes turn on or off. Also, if you've got a faulty light globe in your circuit, it'll mean that the flow of electrons has stopped, and therefore any component in your circuit will not work. So to summarise, what are the advantages of a series circuit? The advantages are it's the simplest type of circuit to set up with minimal wire requirements. The disadvantages though is the voltage is divided by the number of components. That's going to affect the brightness of globes or the amount of heat produced by a heater, etc. The components are at risk of a power surge. If you have one faulty device, it could end up damaging the other components in the circuit. There's also a limited ability to control individual components with the use of switches and that type of thing. So is there any other way to wire up a circuit? Well, there is. We call them parallel circuits. Watch the video on parallel circuits if you're interested in finding out another way to wire up your circuit.